The trigonometric towers integral. In this video, we have this integral from trigonometry, and we have two towers kind of thing of sine and cosine. And we have limits from pi by 6 to pi by 3, and sine x to the power cos x to the power sine x minus cos x to the power sine x to the power cos x. So we can just first break this integral into two integrals. And fun fact, we don't need any of these complex tools. This is really easy integral. Pi by 6 to pi by 3 sine x to the power cos x to the power sine x dx minus integral from pi by 6 to pi by 3 cos x to the power sine x to the power cos x dx. Now we will use King's rule. So what King's rule is in integration? The King's rule is something like this. It's integral from a to b f of x dx is equals to integration from a to b f of a plus b minus x dx. So, and why, for the proof of why this holds, you can just take an integral. So let this be capital F of x, which is derivative of f of x. So this will be f of b minus f of a in the first case. And in the second case, the integral will just be capital F of a plus b minus x. And since we have negative 1 over x, we will just also have negative 1 in the denominator, and from a to b. So now if we evaluate this, when you put b, so b cancels out, we have minus f of a, and when we have f, a cancels out, and we have b, but negative and negative is positive, so this is positive f of b. So we have the same thing over here in both the cases. So that's why they are equal. And you can also see why this holds geometrically. The geometric interpretation is also quite easier to understand. First of all, this one just says that the integral from a to b of f of x dx, so if this is f of x, so this is just this area. And now to get this function, we first reflect x in a y-axis. So first we need to reflect this in y-axis. Can't really do that over here. If you reflect in y-axis, you get something like this thing. Yeah, and you will get integral from somewhere from a to b. Yeah, you are just getting this integral. I mean, this limits will be from minus a to minus b. When you have minus x over here, it will change from minus a to minus b. So from minus a to minus b, this area will be covered. And then you are adding a plus b with x. So again, from minus a, it will go from b to a. And you see that the graph will just be transformed over here again. It will be something like this. And you will again have areas from a to b. So this will be same area. So something like this. You can just see it yourself, and that will give you an intuition on how it holds. Yeah, it was just messy over here. Now we'll try and solve this integral. Now we will use that rule. So, and this is just 30 and this is 60, so the sum will be 90. Yeah, pi by 6 to pi by 3 sine x to the power cos x to the power sine x dx minus integral from pi by 6 to pi by 3. Now we will have pi in terms of x, we will have a plus b minus x, and a plus b is just 90 degrees. This is 60 and 30, so 90 degrees. So we will have cos of 90 minus x to the power sine of 90 minus x to the power cos of 90 minus x. So cos of 90 minus x is just sine x, sine of 90 minus x is just cos x, and cos of 90 minus x is just sine x. Okay, so now we see that these two are just the same integrals, so they will cancel out, and thus the value will be 0. The integral is just 0, and by seeing a lot of complexities, obviously we can't evaluate this integral, so it should just be 0 from the from some random trick as well. I mean, some guesses. Okay, so that's how we solve this integral by using King's rule, and I hope you got this. Or if not, you can comment down. Thanks for watching.